Hi, welcome to another Unity Mobile Dev from scratch. Today I'm going to show you how to create floating up text. The type of text that you see when you get a score on the screen and then the number appears and it floats up the screen and also fades out at the same time. Now to do that we're going to need a text element. So I've actually created a simple environment here, and you can see it's got a main camera which is currently set to orthographic, but you can have it as perspective as well. This will work with either camera. And I've added some spheres that I'm going to click on to make the score appear, and then there's a light in here as well. The first thing we need obviously is a text element, so right click on the hierarchy and let's go down to UI and then text. That will give you the default text element, which looks kind of grey and it's quite small, so we're going to edit that. Select the text in the hierarchy, and then on the inspector you'll see that it has a text script attached to it. The top of this text script has the string that will appear in your text element. So it will say by default new text, and you can see that there. I'm going to change this immediately to white so it makes it a bit easier for you to see just by selecting the color and making it white. Now that might be a bit small for the sort of game that you're making, so it's quite easy to change the font size. We can ramp it up here. Now as you're ramping it up, if it disappears, that's because the box surrounding that text element has become too small to contain the text. If you double click on the text, you'll find its surrounding box on it over in the scene window. So to resize it, if you click on the text itself, like that, and you want to get the resizing around it and you can't see the little blue dots, which you should get here, go up to the top, and this menu panel here where you can change the different actions that you're performing. On the end there's a square box with little dots on the corners, and that will change your text box so that you can actually grab the corners and change it to make it bigger. And then when it is bigger, you can then change the font size and still see it. So we'll go to about that big for now. And then I guess it depends on what you're going to type in there. So let's say it's a score of 100. We'll type 100 into this text box here. Now by default you'll get it as an Arial font. If you want to have a different font, you can bring your own font files in. I've got one that I downloaded from 1000 Free Fonts or something, and you'll find those if you just Google for a particular font, not by name, but if say you've wanted a font that looked like bubble text or something, just type bubble font in and you'll get a listing of all these fonts that you can download. Now this is a true type font which has got a .ttf on the end, this particular file. The font itself doesn't have to be installed on your operating system, so you can just drag and drop the font file itself into Unity and it would then use it. So select your text and then drag and drop your font file onto character font. Okay, now that's either too big, yeah, I guess why it disappeared. The other reason why it might also disappear, and this has happened to me before, is that I'll download a font that I like, but the font itself doesn't have any numbers in it. So it's possible when someone creates a font that they'll only do the alphabetical characters, and if you've downloaded that and you haven't checked that there's actual numerical numbers in there, you could spend ages wondering why your numbers aren't showing up on the screen. Okay, so let me just make this a bit bigger, even though it's probably going to be comically large. No, it's not too bad. Okay, so there's our text that we want to appear when we click on a ball and to float up the screen and to slowly fade out. We'll use script to make the effect happen, and I've created a C# file called float and fade. So create your own, and this will be the contents that we put in it. Now it's not too long. So first of all, make sure that you include the UI engine, Unity engine.ui library file at the top so that you can access the UI elements in your code. The first one we're going to grab is the text itself. So this one here, the text, will grab the text that is on the 100 that we've got there on our actual score. And this text is then set down in the start function to grab the text component that's on that particular game object, which we will do something to in a moment. Now at the top I've got two public float values that we can set in the inspector. One is the fade duration, so how long it will take to fade out. So the smaller this number is, the quicker it will fade out. And then we have a speed as well, and this is how fast it's going to rise up the screen. The bigger the number, in this case, the faster it will actually move. Now we've got a coroutine called fade that's doing all the work. A coroutine, if you're not familiar with that, is a function that kind of you start and then it runs in the background until it's finished running in the background. And the type of that particular function is a I enumerator. So by calling it that, it will allow you to have this function run in the background. And to start an I enumerator function, then you use this start routine function and give it the name of the function with the brackets after it as well. So it's a little bit different to the way that you use invoke or invoke repeating. Now, inside the fade function, it's going to determine and calculate the speed based on the fade duration here. And this speed here is actually not the same as this speed here. This is the speed at which it's fading. So it's probably named a bit wrong and confusing. Let me just call that fade speed, and then we'll put it down here too. So we're calculating how much fade is going to occur each time this for loop is going to run. So we first of all grab the color that is on the text component of our game object, and that's the color I set to white just before. So we're getting hold of that, and we're going to use its alpha value. So we can access its alpha value with a .a, which will allow us to set it, and in this case we're lerping, so we're going from 1 down to a value of 0. When we go for an alpha value of 1, it means that it's going to be totally opaque, and then when it gets down to 0, it will be totally transparent. I'll just show you that in Unity itself. So if we go to our text component and click on our color, in a color you'll see that there's a red, green and blue component, and there's also this alpha value here. Now when it's set to 1, which is the highest, or inside this dialog 255, then it's fully opaque. And as we slide this, if it will let me, down, you can see that text disappearing. Now in this color box, the values are going between 0 and 255, which is a fairly common measurement for color, between 0 and 255. But in the code, it actually goes between 1 and 0, or 0 and 1. So 0 is equal to 0 on this, and 1 is equal to 255. So don't try and code to 255. Back in the code, we've got a for loop that loops around between 0 and 1, and it increments t a little bit each time, and as it does, it slowly moves the alpha value from 1 down to 0, and then it applies this alpha value back to our text color, and that's what's making it actually fade. Now this yield return true, you need it with the enumerator function so that it will kind of yield, as in give up its processing time to the rest of what's going on in your code. And then it will come back to it when it can. And then after that for loop has finished running, then you'll get a destroy. Now if you didn't have this yield here, then you're essentially making this entire for loop run in one go, and you wouldn't see the results of it fading out. It would just sort of go from being there to not being there. Whereas you want to sort of stop somewhere in the middle of this for loop, or at least every time this for loop happens, so that an update function is allowed to run at some point and the screen gets renewed, and then we can come back and do this. Right, so after we've faded out completely, so that's when this for loop has finished, then we will destroy our text object after it's finished floating up the screen. Now that's the fade, okay? That's not actually making your text object move anywhere. The moving bit is down in the update function here, using a translate on our text, vector3.up multiplied by the speed. And this speed is the speed that we've put in. So this is how fast you want it to move up the screen, not how fast it fades out. Right, so if you save that and go back to Unity, I want to grab hold of our text object and then drag and drop that float and fade onto it. Now, depending on the size of your screen and the size of your text and scales and that, you'll get a different effect each time. So you'll notice that didn't seem to go anywhere on mine. On yours, it might actually zip up the screen. But you can modify how fast it's moving based on the fade duration and the speed. So speed is actually how fast it's going up the screen. So let me make that 100, and then it will fade out over 2 seconds. So let's just try that. Okay, so now you can see it floats up the screen. If you want it to be faster, let's make it 200. Yep, okay, so that's not too bad. There's a little bit of a jitter at the beginning. That's the actual editor as the thing runs, not the effect of the code. When you're happy with the way that text is looking, you'll need to create a prefab out of it because it's not going to start existing on the screen. So grab hold of that text, drag it and drop it into your assets folder to create a prefab, and then you can delete the one that's already on the screen under the canvas. Don't delete the canvas though. In order for that text to display, it needs to attach itself at some point in your code to the canvas, otherwise you will not see it. And you'll also need, with a canvas, an event system. Now, I've noticed that some people in the past have a problem when they're creating and deleting canvases. I'll just mention it now. Is if you delete this canvas, you might leave the event system there. These two work together in the UI system. And then if you create another canvas and you haven't deleted the event system, you'll get two event systems. And then the event systems will get all confused over who's getting the events as when you're touching the screen and doing those sorts of things. So that's just a little sideline, something for you to make sure to check if you end up with problems with your interface at some point. Right, so with that canvas there, ready to accept any text that gets created, let's now add this new piece of code, and I'm going to drag and drop that onto the actual canvas object itself. And it's called Manage Click-Ons. It's a C# file, and I'll open it up and show you what it looks like. At the very top, it's going to accept the float up text prefab that we just created, and it's going to use that to instantiate the text every time we click. Now, this code is going to work for orthographic or perspective cameras, as I said before, and it does that by using this generate mouse ray function that we developed a few tutorials ago when we first started talking about touching the screen and moving objects around on the screen. So I won't explain this now. If you want to understand more about this, then I would go back to the Exploring Touch tutorials in this same playlist and look at those. But you do need to add that into your code. And then down here, we've got our update function that actually is doing all of the work for us. And I'm doing an if get mouse down. So if a click, which will also pick up a finger touch as well, or a single finger touch on the screen if you're doing mobile. We're going to do a raycast hit out into the environment to see if we've hit one of those spheres. Again, this is the same exact code that we used for moving the spheres around a few tutorials ago. The only thing that's going to be different is figuring out where on the screen we need to put our text object so that it appears to be directly over the object we've clicked on. And this is a little bit different to the screen point to ray and screen point to world point and things we've been doing in the past, because we're now working with a rect transform utility. And this is all part of the new UI system that came in, what was it, 4.5 or something. And you now need to align not just the click on the screen position with the world position, but you also have like a canvas position or canvas coordinates, which are different again. So you've got like 3 sets of different coordinates. Luckily though, if you know the right functions, it's easy to get around. So what we're doing is we're ray casting into the environment again, hitting one of the spheres, which gives us a hit point that we've used in the past. But this time, instead of calculating like a world position or a screen position, we're actually calculating a canvas position, if that makes sense. And so this screen point, which will be a 2-dimensional vector, is gotten with world to screen point function. Now that will get us a point on the canvas that we can then use. So the next step is to actually instantiate our text from the prefab. Then what we're going to do, remember I said that it's not going to display unless it's a child of the canvas. So that text element that we've just instantiated, the transform parent is set to this dot transform, where this code is attached to the canvas. Now, if you don't have this code attached to the canvas, you need to make sure that the canvas is passed in as an exposed variable and then set in here, just so that you can make sure your text is attached to it. Right, now the next line is very important because it's all about positioning the text in the right spot on the screen. And to do that, we set the text's rect transform anchored position to our screen point that we calculated up here. And then we're also adjusting it with half of the canvas's size. Why? Okay, I'm going to show you. So keeping all of these things in mind, we've got, first of all, the anchored position of the rect transform of the text. If I just go back here and we click on our text prefab, you'll see that at the top, and you've probably seen the old rect transform before for all the new UE elements, this is what we're actually positioning, and we're setting all of these sort of values here to set the anchor to make sure that we're putting it on the screen in the right position. Now, what I'm going to do, I'll just go back into this code again. So we're setting it to the screen point, and we're then minusing half the size of the canvas basically here, and you're probably wondering why. So I'm just going to put a semicolon and comment out that bit and just set the text position to the screen point that we've calculated. I'll save that. Let's go back to Unity, select the canvas and come down to manage, click on, and put our text prefab over there like that. Now let's play and let's select a sphere. Now, did you see that the text did not appear where I clicked? Now you won't be able to see those. Let me just get this canvas in full view in the scene and we'll run it again. And I'll click on that one. And so these points are kind of in the right spot, but they're all offset. Now have a look at the position of this particular ball with respect to this bottom corner. And then have a look, I'll just zoom in here, what happens when I click on this and where it appears up there. So press play, click. Now I can't press pause fast enough, but you'll see clicking down here actually caused the 100 to go on over here. So what is actually happening is that the 0, 0 point on your canvas is right here. So by minusing half the size of the screen from this, it will actually position it down here in exactly the right space. So it's like an offset value. Okay, so if I go and put that back in to the code and save it, now run it again, then I'm getting a click in the right position. Now it's not perfectly on the click position because I'm not using the offset value. It's just setting its position to the position of the sphere. If you want to take into consideration the exact location that you've clicked, you'd have to work out a mouse offset position like we've used in previous tutorials. And that's how to create floating up text.